It may sound dramatic, but our familiar night companion is slowly drifting away. NASA's Discover spacecraft, stationed about 1 million miles from Earth, captured the moon moving against the blue disk of our planet. In fact, precision measurements show the moon recedes by roughly 1.5 inches, about 3.8 centimeters, each year. That's about the speed fingernails grow. Over geological time, that adds up. Days lengthen, tides change, and our Earth's stability shifts. Why does this happen? Earth and Moon are locked in a cosmic tug-of-war. Earth's fast rotation drags the ocean bulge, tide, slightly ahead of the Moon, and the Moon's gravity pulls back on that bulge. The result is friction. Earth's spin is slowed a tiny bit, and the Moon gains energy and moves outward. Think of a spinning ice skater. Pulling arms in makes the spin faster, pushing them out makes it slow down. Scientists didn't just guess this motion, they measured it. The Apollo missions left 5 retroreflectors on the lunar surface. By firing laser pulses from Earth and timing their return, researchers can track the Moon's orbit to millimeter precision. This gradual drift has real effects on our world. In particular, longer days. Lunar tidal friction steals a bit of Earth's spin. As a result, days are lengthening by about 2.4 milliseconds per century on average. That means our 24-hour day is slowly creeping to 25 hours, but it will take hundreds of millions of years to get there. Weaker tides. The Moon's gravity creates our ocean tides by pulling water toward it. As the Moon moves out, its pull weakens slightly. In NASA's explanation, the Moon's gravitational pull causes our oceans to bulge toward it. With a farther Moon, those bulges, high tides, would be smaller. Over many millions of years, that would mean gentler tides, though the Sun's gravity still drives about 60% of our tidal effect. Fewer huge tides could change coastal ecosystems and mixing in the oceans, but this change is virtually imperceptible on human timescales. Axis stability. Perhaps most critically, the Moon acts like a stabilizer for Earth's tilt, obliquity. Currently, Earth's tilt wobbles only by about 1.3 degrees around approximately 23.3 degrees, which keeps seasons relatively steady. Studies show that without the Moon's pull, Earth could wander through a chaotic range of tilt, up to 60 to 85 degrees. Imagine seasons flipping from polar summer to equator summer. That would trigger extreme climate swings. Thanks to the Moon, however, our tilt stays in a narrow band. In fact, NASA notes that in approximately 50 billion years, Earth and Moon would become mutually tidally locked, always showing the same face, halting further recession. But that far future never arrives. Our Sun will exhaust its fuel and expand into a red giant in only approximately 5 billion years, engulfing the Moon and Earth before then. So relax. Our ancestors saw the same Moon, and our descendants, and theirs, will too.